Good morning or good afternoon, everyone. I'm Leon Zhang. I'm an economist at REMI, and today I'll be presenting the last in a series of 4 training webinars on REMI's 4 models. The model I'll be presenting today is REMI's E3 Plus model. Before I begin, can everyone hear me, or are people having audio issues? So the goal for today is to end at exactly 3 p.m. So because I know everyone has busy schedules, so I'll try to get you guys out on time. All right, so today's webinar is going to focus on the E3 Plus model. In previous weeks, we've talked about REMI's flagship model, PI Plus. We've talked about Transight for transportation-related policy analysis. We've talked about Tax PI for REMI's fiscal and budgetary-related policy analysis. So now we're going to talk about environmental and energy policy with E3 Plus. A quick overview of what the agenda is for today. First, I'll talk about REMI, what we do here at REMI. Next, I'll go into specifically what the E3 Plus model is for. Then I'll do a model demonstration of E3 Plus. And finally, I'll leave room for Q&A. And if we run out of time for Q&A, you can always feel free to reach me by email with questions at leon.zhang@remi.com. So spelling of leon.zhang at the bottom over here. So quick information about REMI. So we do economic policy modeling at the regional level. So the primary thing we do is we have our software, so PI Plus, Transight, Tax PI, E3 Plus. We custom build models based on the REMI model for various clients, such as consulting agencies, government agencies. So primarily we're a software company. Clients who use our software have access to unlimited technical support from our staff of associates, analysts, and economists. And it's our jobs to make sure our clients are doing everything they want to be doing with the REMI software. If your economists are swamped, you can also, or you want to do more deep level analysis, we can also do the analysis for you. So what type of questions does REMI look to answer? So if you have a policy in mind and you want to know what's the effect of that policy in terms of how employment gets affected, how output gets affected, how regional or state GDP gets affected, income gets affected, that's what REMI can answer, those types of questions. And we can break down these questions, the answers to these questions, both at the national level, at the regional level, and both at the high level, so just GDP in general, or employment in general, or population in general, and also break it down by industry or by demographics. Yeah. a bit about the REMI model. So REMI's model is an integrated economic modeling approach where we combine four aspects of, we combine four uh, parts of economic modeling into one. So the first is the workhorse of the REMI model, the input and output model. So this captures how different industries in different regions all interact with each other in terms of trade, in terms of how one region will import or export to another. We combine this with a general equilibrium model, which captures the behavior of individuals and the behavior of firms in how they make decisions on capital, on labor demand, on consumption, on prices. We have an econometrics portion, which looks at more of consumer behavior and also how populations evolve over time. And finally, there's an economic geography component, which looks at how factors related to geography, such as transportation time, influences the economy of a region. For example, the easier it is to get in and out of a city, the more productive the workers will be because of lower commutes, and so on. So these four are combined into the REMI model, and these are just an example of the clients we work with. So a lot of government agencies will use REMI software for their policy analysis. The way REMI does its policy analysis is first we have macroeconomic data from, say, the regional seminar of quantitative economics at the University of Michigan or the Congressional Budget Office, just to list a few sources. And we can construct a baseline forecast for if there were no policy, what would the economic future look like? And we can forecast this out to 2060, and we forecast it dynamically, iteratively, year on year. And next, using our economic model, we can model the impact of a policy by casting it as in terms of policy variables. For example, if a policy variable affects output, or it affects employment, or it affects consumer price, we cast it as a policy variable, and the REMI model kind of has these linkages that says, okay, we changed one policy variable, and here's how that effect spreads across the economy. And by doing this forecast dynamically instead of statically, we kind of account for that the economy is going to be changing both by itself and because of the policy year on year. So that's a bit about REMI in general. What does E3 Plus offer on top? So kind of one of the key motivations of E3 Plus is to capture a more complete set of linkages. So, you know, we have how do changes in the broader economy impact demand and production for the energy sector, and how does that in turn affect, say, things like air quality and the environment? Or how do policies that are meant to support the environment, like, say, air quality planning or energy efficiency improvements or technology regulation, how do these affect quality of life and in turn economic competitiveness in a region? And finally, how do energy developments like renewable portfolio standards or fuel price volatility uh, or changing technology, how do these have effects into the economy? So the types of clients we have in mind for the E3 Plus model are, for example, utility companies or state energy departments or regulators or consultants. So these are just a small sample of the clients who use our E3 Plus model for looking at questions such as resource planning, fuel technologies, air quality analyses, and so on. To reiterate, you don't need the E3 Plus model for analysis into energy and the environment. So our flagship model PI Plus has policy variables such as fuel costs, consumer spending, and you can manually use as a policy variable output specifically in sectors such as petroleum mining or coal mining or petroleum production. So there are analyses on energy and environment that are possible without E3 Plus. However, there are extra things that are doable in E3 Plus that are harder to do in PI Plus. So as some examples, uh, so the main thing is REMI offers functionality to make these types of analyses more comprehensive and accessible. So examples of these are first, we have modules for simulating the construction and operation and maintenance of different types of power plants. So typically it's pretty hard to kind of quantify the costs of these power plants, be it because different types of power plants have different demands in terms of capital or labor, and sometimes those costs are going to be private. So E3 Plus helps in that regard. We also have ways of simulating changes in energy consumption and changes in emissions. And with these emissions, we can kind of specify what's going to be the cost of these emissions in terms of economic impact. And those economic impacts translate into, say, what's the how attractive is a place to live, and that's going to affect like labor pools, that's going to affect the economy, and so on. We have a resilience module. We can simulate carbon taxes, and finally, E3 Plus allows for integration of third-party energy models such as CTAM, Markol, and so on. So like I mentioned before, one of the things that's offered in the E3 Plus model is simulating construction and operations and maintenance for power plants. So we have these for nuclear power plants, solar power plants, on and offshore wind, and then gas, and then coal. And so again, it can be hard to get information exactly on how much these cost to construct or operate or maintain. But we've gone and done that. We have data from the National Renewable Energy Laboratory and the Energy Information Administration to help with that regard. So I have a question from Tom Brown. How does the growing increase in electric vehicles and equipment impact your PI plus and E3 plus models for the future? So, actually the demonstration I'm going to be doing today is going to be simulating the effect of uh, increasing the share of electric vehicles in a market. So we can actually do policy analysis on vehicle electrification in REMI. So the next feature that E3 Plus has is the energy and emissions module. So this allows us to forecast the impact on energy consumption and on carbon dioxide emissions by whatever policy you're analyzing. And so this allows you to say, you know, this, if we have to meet, say, a 50% emission reduction target, how much will this particular policy help me reach that target by? And how it works is it essentially takes the amount of fuel demanded by each sector per dollar of output and maps that to energy consumption using input and output data, and finally uses that input and output data energy consumption to get CO2 emissions data. So I have a question from Eddie Baronoff. What about the change to working at home? So we can actually model work from home in REMI software, not specifically in E3 Plus. So in one of our different models called Transite, we have policy variables that are related to commuting costs. And so we can model commuting costs. We can model work from home by saying that a certain subset of workers are going to have their commuting costs drop to zero. So we can model work from home that way. So next up for E3 Plus, we have the emissions cost module. So this will basically take the monetized value of health incidents or environmental quality or everything else related to chemical transmission and put kind of a number value on how much quality of life gets affected by these emissions. And so depending on, say, how your air quality improves or declines as a result of these emissions, you know, this is going to change how people change their decisions on where to live or where to work or where to spend their money. Finally, we have a resilience loss reduction module. So this isn't anything super fancy. It'll just say, if your policy has a resilience or disaster type aspect to it, we can look at how much of the potential losses can you mitigate by some policy. And so common results outputs to look at in the model are such as employment or income or regional gross product, population, and so on. With that, I'll get on to the model demonstration of E3+. So what I have here is a model in REMI's version 2.3. So we have a version 2.4 from this year. So 2.3 is a slightly older version. The region we have here is Minnesota. So we have 5 counties in Minnesota, and a region is broken out for the rest of Minnesota. So typically, a model can have as regions, county level. We can also aggregate regions as far up as, say, the state level, or even a group of states. For example, it's common to have a region that's just one state. We have various amounts of sector breakdowns. So this model here, as typical of E3+ models, is on 160 sector model. But there's models for like 80 sectors, 23 sectors, and so on. So this is the home screen of E3+. And so this, you can see this in every one of REMI's models, such as PI+. So one thing we can look at is the regional profile. And you can look at these counties in Minnesota are broken out from the rest of the state of Minnesota. And we get some basic economic information about each region. So earlier I mentioned that it's typical for E3+ to have 160 sectors. The reason why is because how REMI's breaks down its industries is by NAICS codes. So we have two-digit NAICS codes level, 3-digit NAICS code level, and a 4-digit NAICS code level. And so at the 4-digit NAICS code level, we have utilities over here is broken down into natural gas distribution and electric power generation. These are broken out separately. So if your application is towards energy or the environment, it's nice to have, say, natural gas or electric power generation broken out separately. So one of the key features of REMI is its ability to make national and regional forecasts, which can be done by these 2 buttons over here, New National Control and New Regional Control. And if we scroll over to this View Forecast button on the left, you can see examples of forecasts that I have loaded in. So I'm going to be showing you 2 demonstrations today. First is a demonstration of something that can be done in any of REMI's models. So apologies if you are a repeat attendee. It might be something that looks familiar that's been done in a previous webinar. Afterwards, I'll show you an example of a simulation that's specific of what you would get E3+ in order to actually study. So for the type of analysis that can be done in any REMI software, I'll show you kind of what we've been doing here at REMI in terms of modeling the impact of COVID-19. So how we've been doing this is we take 2 forecasts of the macroeconomy. One assumes there was no COVID-19 and the other accounts for COVID-19. So the standard national control for 2.3 models was based on 2019 data, where we had no idea that COVID-19 was actually coming. So that serves as our no COVID baseline. And then we have macro forecasts from the University of Michigan's research seminar in quantitative economics, and they've been putting out monthly updates for the macro economy forecasts. So that'll serve as our pre-COVID forecast. And so to get a snapshot at the national level, what we can do is we can compare the standard, the post-COVID economic forecast to the pre-COVID economic forecast. So here what this is saying is, compared to the scenario without COVID, we're seeing about a 5% drop in unemployment, about a 4.5% drop in GDP. And so we can look at employment, percent change of employment. We can look at it at the detailed economic level. So, production and trade. Let's look at the differences in output before and after COVID. So we can see that these are some of the industries that are more hard hit by COVID-19. So there's some manufacturing, we have food services and drinking places and so on. So this is kind of a first crack at looking at the impact of COVID-19. And then after taking the first crack at the national level, then we can look at it at the regional level. So, what I'm going to show you here now is we can look at the same numbers, but instead of at the national level, we can look at them at the regional level. So let's look at all regions for now. Percent change. And whereas at the national level we had a minus 4.8% employment drop. In Minnesota, we're forecasting they're getting hit harder. It's a 5.2% drop. And then so again, if we look at the detailed breakdown by industry, we can look at say which industries are hit hardest in this region in particular. And you can do this, look at by all regions, or if you have a specific region in mind, you can look at the specific region. And then finally, so this is just asking how do changes in the macroeconomy at the national level affect it at the regional. But if you have your own specific region-specific data, for example, that your tourism industry has been hit specifically hard, or your state, specifically depends a lot on, say, oil production, then you can go in and kind of add more policy variables to improve the quality of your forecast. For example, here, I've looked at Here I've said let's suppose that the accommodation industry and then the food services and drinking places industry were hit extra hard. And so how's that going to affect the forecast of how's that going to affect the outlook of the economy? And so we look at the economic summary. We can see that before we had around a 5.2, before we had like a around a -5% drop in employment. Now we have an 8% drop in employment. And then not only can we do comparisons, between different, the post-COVID versus the pre-COVID, but we can also do comparisons of, how much does incorporating this extra data I have on, that these industries are hit harder, how does that affect my forecasts compared to if I hadn't incorporated that information? So I have a question from Eddie Baranoff. Are you using existing software behind the scene like At Risk from Palisade? So REMI's software is proprietary. We have our own programmers working, nonstop on improving this software that you see here. All the equations are kind of built into the model. They're academically sourced, they're peer reviewed, they're constantly updated, both the parameters and the actual equations. But there's nothing working behind the scenes like what you mentioned. So that's an example of policy analysis that can be done specifically for, or that can be done in any of REMI's models. Now I'll talk about, a type of policy analysis that can be done, that you would use E3+ for. So I think I alluded to this earlier, but the simulation I'm going to be presenting today is about vehicle electrification. But before I get to that simulation in particular, I'll talk about simulations in E3+ in general. So one vital piece of policy analysis in any model is the ability to run simulations. So all the stuff here on the right that you see is available in any of REMI's models. And so we have the ability to model policy changes to any of these variables. Yeah, employment, we have fuel cost, we have gas tax, we have industry employment, we have outputs, and then in output, we can look at outputs by all these different industries, or you could group industries depending on how you like. So you really have a lot of flexibility in policy analysis that you can do in E3+, or in any of REMI software. Specifically for E3+, we have over here on the left which I described in the PowerPoint presentation earlier. So we can specifically look at policy changes regarding energy prices and demand, regarding power plant construction, operation and maintenance, about social costs from emissions, and about carbon taxes. So in terms of energy prices and demand, so we can look at it first by fuel type. So how does energy demand change for electricity versus natural gas versus other types of fuels? We can look at it by fuel sector. So how does fuel price change for the commercial sector or versus for the industrial sector or for transportation or for residential? And finally we can look at how we can model fuel demand by industry. So we can look at how does the demand for coal change or oil change or natural gas or petroleum. And then finally we can say if the policy change relates to how much does it cost to actually produce this fuel. Again, we can do it by industry, and you can do it, and then how does the fuel cost change by percent or proportion or some money amount. So you can do these types of policy analyses on energy prices and demand. Oops. For the power plants module, for all these different types of power plants, you can model. So we can add, say, a power plant to one of our regions, and then so this particular module will say, okay, we can say that this power plant will cost, say, 50 million. And the data we have will allow you to say, okay, that 50 million, we have such and such amount going into labor and employment. We have such and such amount going into the construction industry, and so on. And so with construction, we can say the power plant costs such and such for the years it's being constructed. And then afterwards, we can say, okay, this power plant is costing so and so amount of money to maintain. And so again, we can do this, whichever, here I've clicked on coal-fired power plant, but you can pick whatever type of power plant you want, and you can specify which region it's being built in. And so and then again, we have data, from the Energy Information Administration that breaks down, if I'm spending $10 million a year to maintain that power plant, how much of that is going to construction, how much of that is going to employment, and so on. Social costs. So if you have an idea in mind that how much does carbon dioxide affect quality of living, or how much does nitrogen oxides or sulfur dioxides and so on, how these affect cost of living, we can map that into, okay, these quality of livings have downstream effects on population, on employment, and so on. And finally, carbon tax. This is pretty cookie cutter. You can model carbon tax as production costs, because you have to change how you produce, or transfer payments if you're if you're a company who just purchases carbon credits and so on. So these are examples of scenarios that you can simulate relating to energy or the environment in E3+. So the simulation I have for you today looks at an a vehicle electrification scenario where we have $100 million less spending on motor vehicle fuels and $100 million more in electricity consumption. So basically, because people are switching to electric vehicles, they're spending less on gas, more on electricity for charging their cars. And so, here I have how we're modeling this is consumer spending. So consumer spending in each of these regions is increasing for electricity to the total sum of 100 million, and it's decreasing for motor vehicle fuels, lubricants, and fluids to the sum of negative 100 million. So this is how we're modeling this change. And of course, depending on how you want to approach the question, you can also look at it as the, say, gas industry has $100 million less output, or and that's another way you can model it. And so, when we do these analysis, we explore these different directions. We can compare how the forecasts differ, kind of get a more complete picture. All right, so here we see a energy summary tab, and what this looks at is essentially how much does energy consumption in each of these categories change as a result of the policies I've put in. So, in this case, we increased electric cars, we decreased fossil fuel cars. And so kind of unsurprisingly, on the residential side, we have strong increases in electricity consumption. This is because people have to charge their cars, so that's more electricity that they're using in their residences. And then on the other side, we have petroleum transportation. That amount goes down. And so, this is because there's less money being spent to petroleum for the purposes of transportation. And so overall, we see these amounts of changes in energy consumption. And we can compare total change in energy consumption. So you see here on the transportation side, we have minus 1.172% versus plus 1%. I think it'd be better to look at differences, but it's kind of hard to see because the units are pretty small here. But you can do this to kind of gauge, this policy, how much is it going to increase the net BTUs of energy output. And then for the non-energy side, like I showed you before, we can look at how things like the macroeconomy as a whole are impacted. So this increases a lot of macroeconomic indicators, such as employment, such as gross GDP, such as population, and so on. And one avenue for this is because there's less fossil fuel pollution and more electric vehicles. It increases the attractiveness of that area to live. And that's one economic channel through which we draw population and companies and workers to the area, and that improves the economic standing of the area. For a more detailed economic look, unsurprisingly, if I look at which industries had the had their output most affected, petroleum and coal manufacturing and oil and gas extraction are affected the most in a negative direction, versus electric power generation was affected the most in a positive direction. And kind of all the other numbers you see here are, okay, these changes to electric consumption and oil construction don't happen in a vacuum. Other industries are affected as well. So REMI will help you look at how all these different industries are affected indirectly as a result of this policy. If we look at, say, population, and then let's see. Another thing we can do is look at breakdowns of what types of populations change the most. And so here we see modest changes, not much in older populations, but more in younger and working age populations. And so you can kind of see how different populations react to these changes. For example, if it had been like a construction project, you would see these ages 25 through 64 increase disproportionately compared to the other categories. But these are examples of economic analyses that are possible in both all of REMI softwares and E3 Plus in general. In either case, it's you have a policy in mind, you cast it in terms of policy variables, and then we can look at the economic impact both at the aggregate level, as you can see here in the economic summaries tab, and also broken down by demographics or industry or so on, here in these detailed tabs. So that's the end of the demonstration, and now I open it up to questions. So I have a question from Robert Handler on, can you say more about the resiliency feature? What is being calculated and what are the underlying assumptions? So, so I can, afterwards, I can send you kind of a more complete document about kind of resiliency analysis here at REMI. Kind of the general thing we do is we figure out what the worst case scenario of a possible disaster is. If there's like a flood, for example, what's the worst possible case in terms of economic damage to the area, and then based on what policy you are looking at, for example, like a flood wall or something, we can forecast, what the predicted loss under that case would be. So, but yeah, I'd be happy to send you the additional documentation. So, I have a question from Stephen Cornegay. Apologies if I'm pronouncing your name wrong. What would be the reason or change from fossil to electric? Also, what will be the draw to average Joe? Sure. So there's many reasons why someone might want to change from a fossil fuel car to an electric car. And so the first is kind of social perception aspect. So, you by having your electric car, you kind of show that you're an environmentally conscious person, or you are an environmentally conscious person. And then there's, in terms of cost, one typical way to model electric versus fossil fuel cars is electric cars cost more upfront, but then you don't pay for gas. It's kind of, you absorb the cost of operating your electric car into, say, your electric bill. And governments, state governments have been exploring kind of putting incentives into getting more electric cars onto the road. Both, credits to companies like Tesla who produce the cars, and also to consumers who might be buying the cars, just because, these state governments really do want people to get more fuel efficient cars onto the road. So I hope that gets at least somewhat into your question of why we might have changes from fossil fuel cars to electric cars. So can you use this model to simulate the impacts of a long-term oil price of $30 per barrel? Has REMI done such an analysis? This question comes from Michael Lawrence. Sure. So I'm not sure if we specifically have done that type of analysis. However, that type of analysis certainly is doable. Here, I'll just give you a brief, I'll give you a brief overview of how you might do this. So, one variable we have as a policy variable is called fuel cost. And so, we can say the oil and gas extraction, or, you can group by industries, and you could select residual units. We can do fixed national, region, whatever region you want. And then you would just input 30 out, to however long you would want to forecast for. And so this would be one way of simulating the impact of the long-term oil price being $30 per barrel. So we're coming up on 3 p.m. I think I have time for one more question. If someone has a question, otherwise, again, you're always welcome to email me at leon.zhang@remi.com if you have further questions after today's seminar or after today's webinar. All right, so I think that looks like it for questions. So thank you everyone for attending today's webinar on REMI's E3 Plus model. So this was the last in a series of 4 E3 Plus training webinars where we showed PI Plus, our flagship model, Transite, our transportation focused model, Tax PI, our fiscal and budget related model, and finally E3 Plus, our energy and environment focused model. Recordings of this webinar and also the slides I used will be available in the next few days on REMI's website in the event archive. Thank you everyone for coming. Have a great rest of your afternoon. A question from Eddie Baranoff. Do you provide any of the models free for academic education? So on REMI's website, we do offer a free demo model. Let me pull it up real quick. Models. Let's see, where's the best paste? I apologize. I'm having a little trouble finding the where the demo is. Okay, so here you can request a free demo for, say, the PI Plus model, and you could use that for academic education. All right, thank you everyone for coming, and have a great rest of your afternoon.